I saw this great video Lino Tan posted where he built an ink display to show transit arrival times, and I thought it looked like a fun project for my own needs here in San Francisco. The initial goal seemed pretty straightforward. Adapt Lino's code to use an API for SFMTA data instead of Singapore's transit system. However, as my brain often does, I underestimated the details, and it quickly turned into a month-long rabbit hole. Thankfully, my friend Brandon came through, not only helping me troubleshoot, but also bought me the Raspberry Pi for this project. Love you, bro. As I started diving in, I was able to find an API from 511.org to show the next arrival time for a bus stop ID. But the data structure was different, and it wasn't quite as plug and play as I had hoped. I also wanted to add a few extras, like the current time and weather. So the list of requirements was quickly starting to grow, and it became easier to write my own code rather than modifying Lino's. Here were the requirements. 1. I wanted a display to show the next 3 arrival times for any Muni bus stop ID. 2. I wanted to show the time and current weather conditions. 3. I wanted the display to refresh every minute so that it's displaying accurate data. And 4. I needed a case to hold the display and Raspberry Pi. The materials that I used for this project were a Waveshare 7.5-inch e-ink display with Pi hat, a Raspberry Pi Zero 2W, Gpio 2x20 pen header, micro SD card, a USB-A to micro USB cable and plug, 3 amps, 5 volts. For the case, I used M2 hardware. I used screws and various links with washers, I used threaded inserts, and I 3D printed some spacers. I also used 4mm neodymium magnets and PLA filament for the 3D printed components. The first step is to install PiOS onto your micro SD card. I use the imager on raspberrypi.com/software, which makes it easy to just follow the prompts. For my applications, I opted for Raspberry Pi Lite OS, found under Raspberry Pi OS Other. Make sure you edit OS customization so you can fill out your username and password and Wi-Fi settings. After you finish flashing your OS onto the microSD, insert it into your Raspberry Pi and connect to it via SSH on your computer's terminal. Again, as I said, I had an assist here from my friend Brandon. You can also follow the documentation they have on raspberrypi.com to help you troubleshoot. Now that you have your Raspberry Pi up and running, you can start diving into the code. I posted mine on GitHub, so if you live in SF and want to use what I have developed for SFMTA, you can install Git on your Raspberry Pi and then clone my repository. Alternatively, you can obviously use Lino's repository or dive into Waveshare's examples that they provide. But either way, you'll need to install the dependencies from the requirements file onto the Raspberry Pi in order to start displaying things on the e-ink display. As I said earlier, I used an API from 511.org for transit data. You can request a token by going here and filling out this form. Then they will email you your token. You will also need to look up your bus stop ID numbers. You'll notice when searching for your stop, there are different agencies. I'm in San Francisco, so my agency is SFMTA, but 511 has data on the whole Bay Area, so you can also get arrival times for BART, Caltrain, or whatever your public transportation needs are. Once you have the API key and bus stop IDs, add them to the environment file. The final piece you'll need for the environment file is an API key and latitude and longitude for the weather data. I ended up using weatherapi.com, but I tried 3 others along the way. Each one had some kind of limitation. Either they didn't update frequently enough, lacked the data I needed, or didn't have enough free API calls per day. To make sure the display stays up to date and restarts in case the Raspberry Pi loses power, you'll need to set up a cron job. If you're unfamiliar with cron like I was, it's essentially a scheduler on Linux systems that lets you run scripts at specific intervals. I set mine to trigger every minute to keep the bus and weather info fresh. This was the cron I used, which can also be found in the README. After saving and exiting, just like that, your display should be up and running. Now we just need a case to hold all the components. I started by taking measurements with my calipers for the display and other components. And once I had all the measurements, I sketched up a basic design in Fusion 360 and 3D printed my first prototype. Because it's a prototype, I reduced the infill and used a draft preset. Sure enough, the display didn't fit and my measurements needed some adjustment, but I try not to dread it too much. After increasing the tolerance on the front to fit the display, on my second iteration, I focused on how I wanted to secure the electronics. Folding the ribbon cable and attaching them to the back like a backpack seemed like the best option, so I added standoffs to the back plate for threaded inserts to be heat pressed in. Fortunately, my measurements on this lined up pretty well, and it was time to figure out how to mount the case to the wall. I initially thought adding 2 holes for nails to slot in would be simple, but in practice it wasn't. The overhangs gave me problems, and I realized that it would require a thick final product. While working on the display, I really appreciated how slim it was, and I wanted to preserve that look if I could. So on the final iteration, I relocated the wall mount to the center instead of the edge to create the illusion that it's floating on the wall. I also decided on using magnets to connect to a second plate secured to the wall. That way I could easily remove the display when I want to continue to tinker. I made a last-minute decision to print the back plates in black to again accentuate the slim screen. Then after printing the final version, I used a soldering iron to set the threaded inserts into the case, and I used superglue to attach the 4mm neodymium magnets. The rest of the assembly is pretty straightforward. However, here are a few notes. You'll want to place the spacers in between the Raspberry Pi and the Pi hat before screwing it to the back of the case. I folded the ribbon cable under the Raspberry Pi to keep the excess length concealed. You'll notice I detached it from the display to make it easier. Just make sure you replace it with the blue text facing up. I found it easiest to place the display under the back when securing the final electronic component. Just place the front frame on first. After securing the remaining screws and attaching the plate on the back, your display should be assembled. Yeah, and so here it is, the final product. I'm really happy with how it turned out. The bus arrival times are very accurate because it refreshes every minute, and if the bus is running late, it will just update that time. I'm also really pleased with having the current weather conditions so that I know if I need to grab a jacket or not on my way out. I'm already thinking about improvements though. I've noticed in the evenings when the buses stop running, I'll sometimes get some errors, so I need to add an exception in the code for that. But that's also made me think about just having a second script that runs in the evening when there are no more buses that will just display the forecast for the next day and maybe my first event for my calendar. While I was working on this, though, I also saw a video from Snazzy Labs that featured a new e-ink display from Terminal, and I went ahead and picked one of those up. So I'm really excited to start playing around with this. Maybe I'll even be able to adapt what I created for the bus arrival times to be able to work on Terminal. So if that's something that would be interesting to you, let me know, and I can work on that. But yeah, that's it. Thank you so much. Peace. Certainly there are several apps you can open on your phone to check the bus arrival times. But my phone doesn't need to solve every problem that I have. Being born in the 90s, I have nostalgia for when products were fun gadgets and new time-saving devices, created, marketed, and sold to solve very specific problems. I remember my first Game Boy. It was a Game Boy Color handed down to me when my older brother got a Game Boy Advance. But even when I had a Game Boy, I still carried around a Tamagotchi and Yu-Gi-Oh cards. I didn't need my Game Boy to be the sole source of gaming entertainment. I enjoyed the unique value each product brought to my life. Nothing will replace seeing a holographic Blue Eyes for the first time, or quickly hiding my Tamagotchi in my desk after my friend Pierce had his taken by the teacher. At night, rather than counting sheep, I'm always thinking about problems that I can fix, designing products to fill those needs. My favorite projects are when I can customize something to perfectly solve a daily annoyance of mine, reducing friction in my day and bringing me a little joy knowing that I solved that problem or improved an experience. Not all of my ideas make it out of my head, but every month I try and dedicate some time to designing and making something, leaving my trace on the world as I do. I can sleep a little more soundly tonight thinking about the joy the e-ink display brought to my day.